we have completed one problem. Okay, we have calculated the moment of resistance of doubly reinforced section. Okay, but in that our steel grade was Fe250. Okay, so we have calculated the value of Mu for what? For doubly reinforced section. Okay, for doubly reinforced section, and in that our steel value is Fe250. So what is the advantage of Fe250? If Fe250 is there, then we will get the value of FSC directly. That is the stress in steel in compression zone. It is 0.87 Fy. Okay, we directly get this value. Okay. But this is the one type of problem. Okay, one variety of problem, type 1. Okay, now this problem we have already solved in the last lecture. This problem we have solved. Now we will look at to type 2 problem. The problem will be same of doubly reinforced section. Just only the change is if Fe415 is given or Fe500 is given. Then how to solve this problem? Okay, this second type of problem now we will see today. Okay, and then we will move to the next unit. So if you have not seen this problem, then please see the steps which we have used to calculate the moment of resistance for the doubly reinforced section when Fe250 grade is there. Okay, same steps will going to be repeat, just the only a minor change with this steel Fe415 or Fe500. The procedure will be same for Fe415, 500 or Fe250, just the minor changes are there. Okay, so now we will take the numerical so that you will understand it better. So the doubly reinforced beam doubly reinforced beam 300 mm by 500 mm by 500 mm is is provided with 2 bars of 12 mm diameter, 2 bars of 12 mm diameter as a compression steel, as a compression steel, as a compression steel, and 4 bars of 25 mm diameter, 4 bars of 25 mm diameter, 4 bars of 25 mm diameter as a tensile steel, as a tensile steel, as a tensile steel. Okay, the effective cover, the effective cover the effective cover is the effective cover on compression side is compression side and tension side, sorry, compression side and tension side, and tension side is 40 mm. Okay, effective cover is given to you. Determine the moment of resistance. Determine the moment of resistance if if M20 concrete and Fe415 steel is used. Now read the problem once again. Uh, what is given? Okay, now read the problem once again. What is given over here? So the doubly reinforced beam is there. 300 mm by 500 mm. So 500 mm is the overall depth. 2 bars of 12 mm in compression side, 4 bars of 25 mm in tension side. Okay, so below the neutral axis 4 bars of 25 mm, above the neutral axis 2 bars of 12 mm. This is the reinforcement. And effective cover on both the sides. That is your D dash on tension side and DT on D dash on compression side and DT on tension side. It is given as 40 mm. So both the sides it is 40 mm. And remember this is the effective cover. Okay, so directly we are going to minus this from the depth. There is no need to do that half of bar diameter clear cover. This is not a clear cover, this is effective cover. Okay, so determine the moment of resistance, that is mu or mr, you can say that, or mu limiting, if M20 concrete and Fe415 steel is used. Now here Fe415 steel is there. Okay, so now we will see how to solve this problem. Okay. So first of all we will calculate the area of steel ASC. So area of steel ASC in compression zone, 2 bars of 12 mm diameter, so 2 into pi by 4 into 12 square. Okay, so solve this and let me know the answer. 226.19. So the answer is 226.19 mm square. Similarly, we will calculate area of steel AST in tension zone, 4 bars of 25 mm diameter it is given. So again 1963.49. Okay, 1963.49 mm square. Okay, so now these are the reinforcements. Now we will move further. So now we will calculate the XQ max by D ratio, but we know that capital D, it is how much? It is 500 mm. 500 mm. Okay, and your effective cover on both the sides it is given as 40 mm. Now what is our effective depth? Then what will be our effective depth? If we want to find out this, then small d is equal to, it is 500 minus 40, that is your effective cover. So it will be 460 mm. This is our effective depth. Okay. Now you know that from IS 456 2000 page number 70, we know that XU max upon D is equal to how much? Now Fe415 is there, so it is 0.48. Remember this. There is no need to remember. If you refer the IS code, I have already shown you where it is there in the IS code. Hope you have noted down at that point. So now X2 max by D is 0.48. So we know that for Fe250 it is 0.53. Now Fe415 is there, so it is 0.48. And for Fe500 it is 0.46. So therefore from this we can calculate the XU max maximum value. XU max is equal to 0.48 into D is 460. So let me know the answer of this. So the question is, effective cover and clear cover, is it same? Okay, so effective cover and clear cover are not same. effective cover is taken up to the center of the bar, center of the reinforcement, and clear cover is taken up to the bottom of the reinforcement. Just 1 minute, I will explain it with the diagram. Let me write this answer first. So it is 220.8 mm. Now I will tell you what is the difference between effective cover and clear cover. See here. So suppose now this is your beam section. Okay, so suppose this is your cross section. Now in this cross section, this is your overall depth. This is your overall depth, capital D. Okay. Now the reinforcement is provided. Suppose now here the reinforcement is provided. One bar, this is second, and this is third on the tension side. Okay. And here, see what is now clear cover and what is now effective cover. So if you measure the distance, see I will show you with the different color from this bottom up to this point, okay, up to the bottom of the bar, then this is your clear cover. This is called as clear cover. Okay. And what is the effective cover? So now for the effective cover, suppose now this is the center of the bar. Okay, this is the center of the bar. Now if you measure the distance from this bottom, okay, bottom of the beam up to the center of this reinforcement, up to here right now, up to the center of the bar, then this is called as your effective cover. This is called as your effective cover. And same is the case on the compression side. Okay, same is the case on compression side. Take the screenshot of this so you will understand. Clear cover is measured up to this point, bottom of the bar. Okay, but effective cover is directly measured up to this point. Okay, up to the center of the reinforcement. And similar thing is there from top also. Okay, similar thing is there from top also. Okay, so I hope now you cleared with this. What is the difference between effective cover and clear cover? Is it okay? Shall we move further?
Yes, sir.
Okay. So the next question is what should we do if in this problem clear? Then you need to minus the half of bar. Bar diameter is also given to you now. Suppose this problem is there. See, his question is what now in this problem 40 mm effective cover is directly given to you. Okay. Now the question is what we should do if the effective cover is not given and this is the clear cover is given. Okay. So if this 40 mm is the, are you understanding the question? All of you please understood this. This is the very important concept, how to calculate the depth. So now in this problem, I will take the new sheet. Okay, here we will come. So in this problem, if you see, 4 bars of 25 mm are given at the bottom and 2 bars of 12 mm are given at the top. So it is very easy now. Suppose, now again, this is the cross section. Okay, what are the bars provided at the bottom? At bottom 4 bars are provided. So I will draw here 1, 2, 3 and 4. Okay. So these are the 4 bars. Okay. 4 bars of how much? 25 mm. This is provided at the bottom. Okay. What is the reinforcement which is provided at the top? 2 bars of 12 mm. Okay. So at the top here, this reinforcement, this is 2 bars of 12 mm. Okay. Now what is our overall depth? It is 500 mm. This is our overall depth 500 mm. Okay. And now his question is instead of effective cover, if this is given as a clear cover. Now what is the meaning of clear cover? Clear cover you measured up to the bottom of the bar. Okay, up to here for all the bars. So this clear cover, this is given to you. Okay, this clear cover is it is given to you 40 mm. Okay, but what is the meaning of effective depth? Effective depth should be always measured up to the center. Okay, if I draw the line, see this is the line. So from top, whatever may be the distance, see from top, whatever may be this distance, it is nothing but your effective depth D. Now I want to find out the effective depth. Okay, so how do I find out? So D is equal to my overall depth is 500, correct, minus I will from that overall depth, see this is my total depth, from this I will minus this clear cover, so I will reach to the level of the bottom of the steel. Okay, so from that again I need to minus the half of bar diameter, so minus 40 minus what we will do, so still we reach to this level, so from this total 500 we have minus this 40 only, so this is the bottom. Then this bar diameter, how much is the bar diameter? It is 25 mm is the bar diameter. So half of this bar diameter, so that we will cover this remaining distance. The distance between this red line and this blue line, it is 25 by 2. So it is minus 25 by 2. Whatever may be the answer, that will be your effective depth. Okay. Is it clear now? So this question was instead of effective cover, if the clear cover is given. That was the question, I think so. Okay. Okay, it is clear now. So please take the screenshot of this so that while studying you will recall the concepts. So now moving further. So here we got the value of xu max. Okay. So after getting the value of xu max, what is our next step? We equate cu2 is equal to tu2. Okay. To calculate the remaining values. So now equate cu2 is equal to tu2. So now after equating this, what is the formula for cu2? You know that it is FSC minus 0.446 FCK into ASC. This is your cu2, which is equal to tu2 is 0.87 Fy into AST2 to AST2. So here now first we need to find out the value of FSC. Okay, FSC ची value आपल्याला काढायची आहे. FSC when FE, here it is not 250, now it is 415. So FE 415 is given. So in this case now, whenever the steel grade is Fe 415 or Fe 500, you cannot get directly the value of FSC, that is the stress in steel in compression zone. लक्षात घ्या FSC आणि FY मधला डिफरन्स काय आहे. FSC is the stress in steel in compression zone and FY is the stress in steel in tension zone. Okay, so now to calculate the value of FSC we need to refer the table which I have given to you in the last lecture. Okay, so first of all we need to calculate the strain. Okay, so I will write here compressive strain in steel, that is epsilon SC. What is the formula for this? If you are having the IS code right now with you, open page number 96 G1.2. Okay, if you go to the IS code, let me open the IS code. Okay, so this is IS code. In this IS code now, you can see the formula which is given over here. So every formula is there in the IS code, almost every formula. There is no need to by heart anything. So see this formula. This is the formula for the strain which is given over here. Okay, so now if you simplify this formula, if you 0.0035 as it is. Okay, now here xu max minus d dash divided by xu max is there, so divide by xu max to each term. So in bracket what will you get? Xu max divided by xu max, it is 1 minus d dash upon xu max. Okay, here also you will get the same formula. Okay, and this formula what we are using. This is the total AST is equal to AST1 plus AST2. This formula is also given over here. Okay, to determine the depth of neutral axis, this formula is also given over here, which we are using. What we will do, we will equate Cu equal to Tu. Now that formula is given over here directly. Okay, so all the formulas are given in the IS code. If you read the IS code carefully. So now by using this formula, which is given over here, we can calculate now what is the strain. Okay, so we will move further to calculate this strain. So let us see any other formula is given over here, and we will move to the whiteboard. So epsilon SC is equal to, what is the formula? Just now we have seen 0.0035 in bracket 1 minus d dash upon xu max. So this is the formula. Just put the values now. Therefore, epsilon SC, that is the strain. Now I am talking about strain still in compression zone. Okay, so it is 0.0035 in bracket 1 minus d dash is 40 mm. XU max I think we have calculated now. XU max. Yes, it is 220.8. So put the value 220.8 and calculate it. 0.00286. Okay, please cross verify the answer. So the answer is epsilon SC, that is strain, is equal to 0.00286. Okay, now from the value of this strain, now go to the table which I have given to you already. Okay, for Fe415 table, look the value of strain and look the corresponding value of stress. Okay, see that whether we are getting direct value or what. Okay, now if you refer the table for Fe415, refer it for Fe415. So it is 0.00276 value is there. For that it is 351.8. Okay, and the second value is 0.00380. 0.00380. Okay, for that its value is 360.9. And now we need to do the interpolation because we want the value for 0.00286. It is how much? This value we want. Okay, so now I hope now you know the interpolation. In the DOS also you learn this in how to do the interpolation. Now do the interpolation and let me know the value of this. This is the value of your strain and this is the value of your stress, FSC. Okay, so here I will write by interpolation, FSC is equal to, what is the value? 0.00276 ला 351.8 आहे. 0.00380 ला व्हॅल्यू आहे 360.9. आपल्याला या दोन्हीच्या मध्ये व्हॅल्यू पाहिजे 0.00286. तर त्याला किती व्हॅल्यू असेल? डू द सिंपल इंटरपोलेशन अँड लेट मी नो द आन्सर फास्ट. 2.67. Okay, so this is the answer, 352.676. Okay, so this is the answer, 352.676 Newton per mm square. Okay, that is megapascal, Newton per mm square. Okay, now we use this equation what we have written over here, this equation. So here now if you see FSC minus 0.446 FCK, ASC 0.87 F into ST2. Now from this equation we will get the value of this AST2. Previously there are two unknowns. We don't know, we were not knowing the value of FSC and we were we were not knowing the value of AST2. Okay, total AST is known to us. Total AST is the 4 bars of 25 mm diameter. But you know that total AST is equal to what? AST1 plus AST2. So from here we will get the value of AST2. Okay, so first of all we have calculated the value of this FSC. Now we will calculate this value of AST2. Okay, so now moving further, so here FSC, what is the, so I will write the equation once again for your understanding. 0.446 FCK, okay, into ASC is equal to 0.87 FY into AST2. Now put the value. This is Cu2 is equal to Tu2. Cu2 equal to Tu2. So here it is 352.676 minus 0.446 into 20. FCK is 20. ASC we have already calculated. I think we were having the value of this. So it is 226.19, which is equal to 0.87 into Fy is 415, our steel is there, into AST2. So let me know the answer. What is AST2? Others, please check the answer. 215.355. Oh, sorry, 35. 35 mm square. Okay. So this is the value of AST2. So now we know that total area of steel is known to us. Okay, we know, but AST, total area of steel, is equal to AST1 plus AST2. This is the formula. So now what is the total area of steel? So total area of steel AST is 1963.49, which we have already calculated, which is equal to AST1, we don't know, it is as it is, plus right now we have calculated the value of AST2, it is 215.35. So from this you will get the value of AST1. Let me know the answer. 1748.14. Okay, 1748.14 mm square. Okay, this is the value of AST1. Now calculate the value of XU. Now we need to calculate the value of XU. Okay, so here equate, to calculate the value of XU, we will again equate Cu1 is equal to Tu1, or you can use that direct formula which I have shown you on the page number 96 right now. Okay, I have shown you while we are calculating this, that epsilon SC, strain in steel in compression zone. At that time also I have shown you the formula. That formula also you can use. This is the extension version of that formula, nothing else. Okay. So it is 0.36 FCK B into XU, which is equal to, it is 0.87 Fy into AST1. Now just you need to put the values. So therefore 0.36 into 20 into B. What is the width of the section? It is 300. XU as it is, which is equal to 0.87 into Fy is 415 into AST1 1748.14. So from here you will get the value of XU. 92.20. Okay. Is 292.20 mm. Now just compare the value. Okay. XU is greater or XU max is greater. Okay. So here your XU is greater than XU max. So this is over reinforced. So generally we avoid to design the over reinforced section. So what we do? So we assume as a balance section. Okay. So assuming as balance section. Okay. So if you do that, then your if it is balance section, then your XU must be equal to XU max, and the value of your XU max is 220.8. Okay, in balance section we know that XU and XU max should be same. So if you take the value of XU, which is 292, then this section become over-enforced. We don't want over-enforced section. Remember this. Why we have not taken here 292? Because if you take the value XU and XU max is equal to 292, then it will become over-enforced. We don't want it. So we have assumed the balance section and we have taken the value of XU and XU max as 220.8. Okay, for balance section. So now therefore mu is equal to, you know that mu is equal to, what is the formula? It is Cu into Z. This is your basic formula, which is nothing but it is equal to Cu1 into Z1 plus, as it is doubly reinforced section, Cu2 into Z2. Okay, this is the formula. Now mu is equal to Cu1. So see, for the Cu1, 0.36 into, I will write the formula first, FCK V into XU max. You need to take XU max. Okay, in bracket D minus 0.42 XU max. This is your Cu1 and Z1 plus here your Cu2. It is FSC minus 0.446 FCK ASC into D minus D dash. This is the lever arm. D minus D dash. Okay. So just put the values now. Therefore, mu is equal to, I think now you can put the values. Simple thing is there. I have given you the formula. Just put the values over there. Let me know the answer. What answer? Let me write all the values. 136 into 20 into these 300. Okay, into XU max is 220.8. Okay, into D, the depth of the beam, it is 460 minus 0.42 into 220.8. So this bracket is complete over here, plus FSC. What is the value of this? Let me know the answer if you have solved this. 175.158. Please check the answer. This problem is not solved. Means I am having this problem. I have taken this from unsolved numericals. So I am not having the correct answer of this. You need to check the answer. Okay. I am just having the numerical and final answer. And here 175.15 is the answer, but the final answer here it is 207.8. So that is the correct answer. 207.81 is the correct answer. So roll number 2, please check your calculation once again. So it is 207.81 kilonewton meter. Okay. So this is our final answer, 207.18. So this is the second type of problem, which the only change is that the FSC value. Okay. So now here almost all the varieties over. So still we will take one more problem of this kind, and then we will move to the next unit. Okay. And we will take design of continuous beams first, and the last we will take the design of T beam. Okay, and L beam. So unit number 4 we will take it at last. Okay. So now take the numerical. Next problem. A doubly reinforced beam section. A doubly reinforced beam section, 250 mm wide and and 500 mm deep, to the center of tensile reinforcement, to the center of tensile reinforcement, to the center of tensile reinforcement, full stop. It is reinforced with, it is reinforced with 2 bars of 16 mm diameter, 2 bars of 16 mm diameter on compression side, at an effective cover of 50 mm. At an effective cover of 50 mm, and 4 bars of 20 mm diameter as tensile steel. Full stop. Calculate, calculate, calculate the moment of resistance of the beam. It was getting disconnected, so we will continue. So in short, now I will write the problem what we have, it is given. So small b they have given to us, it is 250 mm. Okay. The next is the 500 mm deep to the center of tensile reinforcement. So effective depth is given to us. It is 500. 500 is not the overall depth. Then it is reinforced with 2 bars of 16 mm as a compression reinforcement. So ASC, which is equal to, they have given us, it is 2 bars of 16 mm diameter. This is ASC, and now AST, they have given us AST as 4 bars of 20 mm, and the effective cover in the compression zone, that is D dash, this value is given to us as 50 mm. Okay, and using M20 and Fe415. So M20 means FCK, the value of FCK is 20, and Fe415 means the value of Fy is 415. This all the things are given to us, and they told us to calculate the MU, MR, or okay. So this we need to calculate. So this is our given problem. Okay. Now you tell me how to solve this. Okay, what will be our first step? Here, what will be our first step? What we generally do? Now we have solved many problems. Okay, what we generally do first we calculate what is the area of steel in compression zone, area of steel in tension zone. Then we will calculate the value of XU max. Okay, so here ASC. So ASC is equal to is 2 bars of 16 mm. So let me know the answer. 2.12. Okay, 402.12 mm square. So this is the value of AST. Now we will calculate the total area of steel in tension zone. So this is AST. So the total area of steel in tension zone, what they have given to us, 4 bars of 20 mm diameter. 1256.63. Okay, 1256.63 mm square. So these are the values of AST and AST. Okay. Now again from IS 456 2000 page number 70, we know that XU max by D ratio when the grade of steel is Fe415. Okay. So when the grade of steel is Fe415, then XU max upon D, this ratio, it is 0.48. This is given in the IS code. You can verify this. So now from this you can calculate the value of XU max. Therefore XU max is equal to, it is 0.48 into effective depth, it is directly given, which is 500. Okay, they have mentioned in the problem that 500 is the depth up to the center of tension reinforcement or tensile reinforcement. Okay, so from this you will get the value of XU max 240 mm. Okay, so this value is 240 mm. Now after this we will equate Cu2 and Tu2. So before equating Cu2 and Tu2, now see, now you are familiar with this. You know that in the formula of Cu2, that is compressive force 2, that is our additional section. So in that, in the compression, what we can say force, we need to find out the compressive stress in steel. Okay, so FSC we need to find out. So without finding out the FSC, we cannot find out the AST2. So first we need to find out the FSC. So to find out FSC value, now see, we need to find out the value of FSC, and again Fe415 is given. So we will not get the direct value of FSC. So for this we need to calculate the strain first. Okay. So as I have told you already, here I will write once again from IS 456 2000. Okay. From IS 456 2000 G 1.2 page 96. Okay. Epsilon SC is equal to 0.0035 in bracket 1 minus D dash upon XU max. So now epsilon SC is equal to 0.0035 1 minus, what is the value of D dash? I have to see that. I have not remembered. So that value is 50 mm. Okay, so it is 50 and your extreme axis is I think 240. So now after solving this you will get the value of this epsilon SC. That is the strain in steel in compression zone. This is the strain. This is not the stress. This please let me know the answer. 0.00277. Okay. So 0.00277. This is the value. So again we need to do the interpolation. Okay. Again go to the table which I have given to you. Please check the values for Fe415. Okay. So now again if you see for Fe415 0.00276. Okay. The value is what is the value? 351.8. Again for 0.00380 the value is 360.9. Okay. And for what we want to find out the value? 0.00277. For this what will be the value that we need to find out. So find it out by doing the interpolation and let me know the value of FSC. So therefore FSC is equal to, please calculate the answer. Why you are taking much more time? Do it fast sir. This is also the problem which is unsolved problem. I don't know the answer, so we need to check the answers. Okay. So okay, correct. 351.88 Newton per mm square. So this is the value of FSC. So now after the calculation of this stress in steel in compression zone, now equate your total compressive forces in additional section, that is CU2 to TU2. Now after equating this, what is the formula? So FSC minus 0.446 FCK into ASC, which is equal to 0.87 FY into AST2. So see, you write down these formulas while solving the problem. Now write down these formulas. तुम्ही जेवढ्या वेळा लिहिताल तेवढ्या वेळा ते तुमच्या जास्त लक्षात राहील. Okay. So now just put the values. FSC is 351.88 minus 0.446 into 20 into ASC. आता ASC ची व्हॅल्यू आपण काय काढली होती? ASC 402.12. Okay, so it is 402.12 which is equal to 0.87 into Fy. Fy is 415 into, we don't know the value of AST2. We know the value of total AST, but we don't know the value of AST2. From this, we will get the value of this AST2. That is the area of steel in additional section. 381.97. Okay, please cross verify the answers so that our problem is correct. Okay, 381.97 correct. So 381.97 mm square. This is the value of AST2. But we know that at total value of AST, okay, 1256.63, so we can calculate the value of AST1. Okay. So here, total area of steel is equal to AST1, that is area of steel in singly reinforced section, plus area of steel in additional section. Okay, so what is our total AST? It is 1256.63. So this is 1256.63, which is equal to AST1 as it is, plus this value is 381.97. So therefore AST1 is 874.6 0.66 mm square. Okay, so this is the value of AST1. Now calculate the value of XU. Okay, so to calculate the value of XU, equate CU1 is equal to TU1. Equilibrium of singly reinforced section we are equating. So here 0.36 FCK B into XU, which is equal to 0.87 FY into AST1. So just put the values over here. 0.36 into FCK is 20 into B. What was the value? I forgot the value of B. B 250. Okay. So the value of B is 250. XU as it is 0.87 into 415 into 874.66. So therefore, XU is equal to 0.44 mm. Okay. So now moving further, just 1 minute. Ah. So now compare the values of XU and XU max. So now compare the values of XU and XU max. What was the value of XU max? It is 240. And what is the value of this XU? It is 175.44. Okay. So now who is greater, who is less? So XU max is greater than XU. See over here. Here your XU is less than XU max. So what type of section it is? Under reinforced. This is the under reinforced section. Okay. So now if the section is under reinforced, what is your formula for MU? So your MU is equal to TU into Z. That is your MU is equal to, here in this case, TU1 into Z1 plus TU2 into Z2. Just now you need to put the values. Okay. Just now you need to put the values in the formula. So therefore, MU is equal to TU1. What is TU1? It is 0.87 FY AST1, okay, into D minus 0.42 XU. Okay, D minus 0.42 XU. So this is TU1 into Z1 plus, now TU2 into Z2 is, here it is 0.87 FY AST2 into D minus D dash. D minus D dash. So just put the values, you will get the answer. Therefore, mu is equal to 0.87 Fy into AST1. What was the value of AST1? It's 74.66 into D minus 0.42 XU depth. What was the depth of our section? 500. 500 minus 0.42 into XU. XU value 175.44 plus here again 0.87 into 415 into AST2. So here is the value of AST2, 381.97, 381.97 into 500 minus D dash, so it is given as 50. I think it is 50. Okay. So now if you solve this, you will get the value of mu 196.68 kilonewton meter. Okay, kilonewton meter. So this is our final answer. Okay, I hope now you are now clear with this W info sections. Okay, this is the last type of problem which we have taken now. The width and depth of the beam, those types of problems are not there for you now. It is the analysis of the doubly reinforced section for your syllabus now. Which problem you want related to finding out the width and depth of the, so which type of problem it is, take the problem related to finding the width and depth of the beam if the span is given. So I have not seen such a type of problem since I am teaching this in this single and doubly reinforced section. So if you are having such a type of problem, you can send that problem to me through WhatsApp. We will solve it over here. Okay. But the thing is that everybody means everybody should have that kind of difficulty so that we will take over here, or unnecessarily we will not engage everybody's time. Okay. So now and see once if the span is given to you and width is given to you in the beam, then it is very easy to calculate the depth. You can equate the formula of mu limiting given on the grade of steel. It may be 0.133, 0.138 or 0.149 FCK BD square. From this you will get the value of D, and you can assume this value. Either you can assume the value of B or it may be given in the problem. That is so simple. Okay. So either it is 200 or 250, whatever you want, or 300, you can assume this value and you will get the another value by using this formula. Okay, MU limiting formula. So this is the simple thing which is over here. Still now, I think we will. I'm searching that kind of example. So I have not found out. So if we are having such a type of example, we will take this one more problem. We will take design the reinforcement, design the reinforcement required required for for doubly reinforced doubly reinforced beam section beam section for for following details, for following details. First, width of beam, width of beam is equal to 250 mm. Effective cover in compression zone, effective cover in compression zone, effective cover in compression zone. It is given as 50 mm. The maximum bending moment under working condition, maximum bending moment under working condition. So mu is given to you. Working condition, it is equal to 160 kilonewton meter. Okay. Then fourth, factor of safety, which is equal to 1.5, and then FCK is 20 Newton per mm square, and then Fy, it is 250. So now see the problem. So I have now covered this type of problem. In this problem, the depth of the beam is not given to you. Okay, and also the area of steel in compression zone is not given. Area of steel in tension zone also not given. So they have given you the problem in reverse way now. Now they have given you the value of bending moment, that is mu is known to you. Up till now what we are doing, we are calculating the value of mu. Now mu is given to you and they have asked you to calculate the reinforcement in the compression zone as well as in tension zone. Okay, so copy down this problem, a very important problem. So now here we will cover both the things. If the reverse condition is given like this also, and also the depth of the beam is not given in the problem, only the width is given. Okay, so now how to solve this type of problem? So here if you first see the maximum bending moment under working condition, it is given as 160 kilonewton meter. So this is for working condition. Okay, so working bending moment is given to us. So from the working bending moment, we will calculate ultimate bending moment. So from here you will get the value of D required. It is 567.58 mm. Okay. So now see, as this is the depth, 567.58. This depth is provided for this, what we can say mu, the total, it is 240 into 10 raised to 6. See what I mean to say. Now listen carefully what concept I am explaining to you here. Please listen carefully. Now this value what we have calculated 567.58, it is calculated for the total bending moment of doubly reinforced section. The total bending moment of doubly reinforced section is 240. You know that for total bending moment mu is equal to what? It is mu limiting plus mu2. So this total bending moment, this is our 240 value, and for this value we have calculated the depth. But actually in the doubly reinforced section, the depth is calculated based on this mu limiting. Okay, actually in doubly reinforced section, depth is calculated based on mu limiting. म्हणजे काय? डब्ल्यू इन्फो सेक्शनला आपण कधी जातो नॉर्मली, की ज्या वेळेला आपल्याला डेप्थ पूर्ण प्रोव्हाइड करता येत नाही, आपण डेप्थ मध्ये काय करतोय, डेप्थला कमी करतोय. डेप्थ आपण जी लागणार आहे ती डेप्थ प्रोव्हाइड करत नाहीये. मग डेप्थ जी लागणार आहे ती कुठून कळणार आहे तुम्हाला, तर एमयू वरनं कळणार की किती डेप्थ लागणार आहे. मग तुम्ही प्रोव्हाइड कुठली डेप्थ करणार, एमयू लिमिटिंगला लागणारी डेप्थ नेहमी प्रोव्हाइड करणार. कळतंय का? So that is why we are adding this additional section to balance this. So whatever required depth that we are not actually going to provide in the doubly reinforced section. Remember this. जर तुम्हाला जेवढी डेप्थ लागत आहे तेवढी डेप्थ जर तुम्ही प्रोव्हाइड केली इथं, तर हे डब्ल्यू रिइन्फोर्स सेक्शन होणारच नाही. दिस विल बिकम सिंगली रिइन्फोर्स सेक्शन. आर यू गेटिंग माय पॉइंट? ओके, सो हियर as we are designing the doubly reinforced section now, suppose now we have restriction. Okay, समजा ही तुम्ही बीम डिझाइन करताय, ती बीम एखाद्या अपार्टमेंट मध्ये पार्किंग आहे ना, ग्राउंड फ्लोर पार्किंग, तिथली बीम आहे आणि तिथं तुम्हाला डेप्थ रिस्ट्रिक्शन आहे समजा 500 mm, म्हणजे 500 mm पेक्षा जास्त तुम्ही बीमची डेप्थ घेऊ शकत नाही. आणि तुमची आता डी रिक्वायर्ड किती आलेलं आहे, 567.58. Okay, so still you are not going to provide this D required because your restriction is limited to 500 mm. ओके. मग जर जेवढं लागतंय 567 तेवढं जर तुम्ही प्रोव्हाइड केलं तर ह्याला तुम्ही डबली रिन्फोर्स सेक्शन म्हणणारच नाही. दिस विल बिकम सिंगली रिन्फोर्स सेक्शन. I hope now you are clear with this point. Okay. So here what I will do, instead of providing this whole depth, because we are designing the doubly reinforced section, we are having the depth restriction. So here I will write taking depth restriction of 500 mm. Taking the depth restriction of 500 mm. हे जे मी काय आत्ता बोललोय समजलंय ना सगळ्याला? Yes, no? Are you getting this point? Yes? ओके. म्हणजे लक्षात घ्या की आता तुम्ही पार्किंगची बीम एखादी डिझाईन करताय तर तिथे तुम्हाला डेप्थची रिस्ट्रिक्शन आहे. तुम्ही 500 mm च्या वर डेप्थ प्रोव्हाइड करू शकत नाहीये. ही तुम्हाला रिस्ट्रिक्शन आहे. पण तुमची डेप्थ रिक्वायर्ड किती यायला लागली आहे? 567 आहे. मग याच केसमध्ये आपण डबली रिन्फोर्स सेक्शन डिझाईन करत असतो. ओके. जर आता समजा इथं 567.58 डेप्थ आपल्याला रिक्वायर्ड आहे आणि आपण तेवढीच्या तेवढी सगळी डेप्थ, समजा मी इथं 564 च्या ऐवजी 600 mm डेप्थ जर प्रोव्हाइड केली तर इट इज सेफ. इट विल बिकम सिंगली रिन्फोर्स सेक्शन. म्हणजे जेवढी लागते तेवढी तुम्ही प्रोव्हाइड करताय. मग तुम्हाला गरजच नाही कॉम्प्रेशन झोन मध्ये स्टील प्रोव्हाइड करायची. कळतंय का? आपण डबलीला जातोयच का? तर मी 567 ची 567 डेप्थ प्रोव्हाइड करू शकत नाहीये. माझ्या पुढे काहीतरी रिस्ट्रिक्शन्स आहेत. त्याच्यामुळे आपण डबली रिन्फोर्स सेक्शन डिझाईन करतोय. Okay, this is what is the concept. So now here we cannot provide this 567 depth as it is. Okay, so for that now what we will do, I will assume here taking the depth restriction of 500 mm. You can take 450 mm also. पण जास्त मोठं डेप्थ रिस्ट्रिक्शन घेऊ नका. जेवढं तुम्ही मोठं डेप्थ रिस्ट्रिक्शन घेताल तेवढं तुमची MU लिमिटिंगची व्हॅल्यू जास्त येईल. Okay, so that is why just 50 mm, 60 mm, 50 to 80, 100 mm it is sufficient. So taking the depth restriction of 500 mm. Okay, so here I will write provide a depth of 500 mm to the beam. Okay, now I have decided that I am going to provide the 500 mm dip. आता ही जी मी 567 लागत असताना 500 जी प्रोव्हाइड केली आहे, हे वरचे जे 67 mm जे आहे ना, जे मी कट केलेलं आहे ते मला भरून काढावं लागेल. कॉन्क्रीट जेवढं मी कट केलेलं आहे तेवढं. ते मी कसं भरून काढणार? तर बाय प्रोव्हाइडिंग द ऍडिशनल स्टील इन द compression zone, and this is called as doubly reinforced section. Okay, so now moving further, after providing this depth, calculate the value of FSC, that is the stress in steel in compression zone, and this value is 0.87 Fy. It is now very easy to calculate as Fe 250 is given. So Fe 250 दिलेला असलं की तुमच्याकडे डायरेक्ट फॉर्म्युला आहे. So you can directly use the formula, but when Fe 415 and 500 is there, you need to use the table. So now if you solve this, you will get the value 217.5 Newton per mm square. Okay, Newton per mm square. So now here first calculate the XU max now. After this we will calculate the XU max. So we know that XU max upon D, this ratio for Fe 250 now it is 0.53. Okay, for Fe 250 it is 53. Okay, so now here XU max is equal to 0.53 into 500. Now this 500 is our effective depth. Remember this, here in the formula we used small d. This is small d. So whatever we have provided here, this is our small d. Okay, so now what is the answer? 65. So this is 265 mm. Okay. So now I have told you in the beginning the concept of doubly reinforced section. There I have told you, suppose now doubly reinforced section is there. Okay, you should remember this. This doubly reinforced section is comprising of, this is your singly reinforced section plus additional section. Okay, and this is your doubly reinforced section. I have told you that already. So the bending moment of doubly reinforced section we called it as mu. The bending moment of singly reinforced section we called it as mu limiting, and for additional section we called it as mu2. This is also we have seen. Okay, so now from this we know that if we want mu, so mu is must be equal to your mu limiting, that is the maximum bending moment of singly reinforced section. You can, instead of mu limiting, you can call this as mu1 also. Notation doesn't matter, understand the concept. Mu limiting plus this is your mu2. Okay, so the maximum bending moment will be there in singly reinforced section, and plus in addition to this you need to consider some additional section. This introduction we have already seen. Okay. Now see mu. I know the value of this mu. What is the value of this mu? The value of this mu is 240 kilonewton meter. This is the value of mu. Okay. Now if I find out one of this value, now suppose this value is 240. So if I found, either if I found out the value of mu limiting, or either I can find out the value of mu2, then from here, म्हणजे जर मी mu limiting ची व्हॅल्यू जर मला मिळाली तर मला mu2 ची व्हॅल्यू सहज काढता येईल, किंवा mu2 ची जर व्हॅल्यू मला काढता आली तर मला mu limiting ची व्हॅल्यू काढता येईल. ओके, कारण की आपल्याला टोटल व्हॅल्यू माहिती आहे 240. So we can easily calculate the value of mu limiting by using the formula of moment of resistance. Okay, so now how we are going to calculate, let us see over here. So now we know that we know that for Fe250, for Fe250, mu limiting is equal to 0.149 FCK VD. Okay, now we have finalized our depth. Okay, so the mu limiting is equal to, it is 0.149 into FCK. FCK is 20 into B. B, I think it is given in the problem, that is 250 into D square. D is 500. We have taken this 500. So now if you solve this, you will get the value of mu limiting. Let me know the value. 186.25. 186.25 kilonewton meter. So simple maths is there. Now see, if we go to the previous thing, so this is 240. Now this value we got it as 186.25. So remaining mu2 you can easily calculate. Let me know the value of this mu2 also. टोटल आहे 240 डब्लीची बेंडिंग मोमेंट. सिंगलीची मॅक्सिमम बेंडिंग मोमेंट किती मिळाली तुम्हाला, 186.25. आता मग mu2 ऍडिशनल सेक्शनची बेंडिंग मोमेंट मला सांगा किती असेल. डू इट. 240 minus 186.25. What is the answer? 25. What is the value of mu2? mu2 will be 240 minus 186.25. What is the answer? 53.75. Okay, so the answer is 53.75 kilonewton meter. So this is the bending moment of additional section. Okay, so now we know that what is the formula for mu limiting, but mu limiting we can also calculate this mu limiting as, it is tu into z. Okay, tu1 into z1. बरोबर आहे ना. mu limiting हा कुठला फॉर्म्युला असणार आहे, tu1 into z1. if you consider these three sections, Okay, this is your doubly, this is your singly reinforced section, this is your additional section. Okay, and now this is equal to this plus this. This is your mu, this is your mu limiting, and this is your mu2. Okay, so if I want to calculate the total AST, then this will be AST1 plus this is AST2. Okay, so similarly, see, here it is the total tensile force TU. What is the tensile force here? It is TU1. What is the tensile force here? It is TU2. Now if I am thinking about this section, MU limiting, I am just thinking about this MU limiting. Okay, so for MU limiting, what will be the formula? So MU limiting must be equal to, it is TU1 into Z1. Z1 is the lever arm. Somewhere here your CU1 is there, and the distance between CU1 and TU1, it is nothing but Z1. Okay, it is nothing but Z1. So now here similarly, now MU limiting is TU1 into Z1. Now what is the value of that? It is 186.25, okay, into 10 to the power 6, which is equal to TU1 is 0.87 into Fy into AST1, it is TU1 into Z1. Okay, so Z1 is D minus 0.42 XU max. So now why we are taking here XU max? Now see, if you compare your MU and MU limiting, okay, if you compare the value of MU and MU limiting, so here your MU value, that is 240, it is greater than your MU limit. Okay, therefore taking as balance section, this will become over reinforced if your MU is greater than MU limiting, that is doubly reinforced section. Similarly, it can also imply that MU is greater means XU is greater than XU limiting. But when your XU is greater than XU limiting, then we will take it as a balance section, and your XU must be equal to XU max must be equal to 265 mm. Okay, this we have already done in the previous numericals also. There is nothing new in this. So now, if you just put the values over here, you will get the value of AST1. So now I will write all the values. So it is 186.25 into 10 raised to 6, which is equal to what, what does it is 0.87 into Fy. Fy is 250. Okay, into AST1. AST1 is as it is into D minus 0.42 XU. So D is 500 minus 0.42 into XU is 265. Okay. So now solve this. So you will get the value of AST1. AST1, which is equal. Now what is the value? 2203.04 mm square. Okay, so this is the value of AST1. Now similarly, if we go back to this diagram, okay, now if I think about this section, now if I think about this additional section, so now TU2 is here and CU2 may be acting somewhere here. The distance between these two is the Z2. Okay, so similarly I can write mu2 is equal to, it is nothing but mu2 is equal to what? It is tu2 into z2. Okay, after all combining these all, you are getting this doubly reinforced section, total cu and total tu, and this is your z. Okay, so now here I can now equate similarly mu2 is equal to tu2 into z2. Tu2 into Z2. Okay, so now Mu2, it is 53.75 into 10 raised to 6, which is equal to Tu2 is 0.87 into Fy is 250 into AST2 as it is into D minus D minus D dash. So here your Z2 is, you should know the value of Z2, it is D minus D dash. Okay, so just lever arm changes over here, bending moment is also changes. So you have to put the values accordingly. AST2 into D minus D dash. So D minus D dash is 500 minus D dash is 50. So if you solve this, you will get the value of AST2. What is the value? It is 549.27. Okay, mm square. So now, therefore, total AST is equal to total area of steel. AST is equal to, it is equal to how much? It is AST1 plus AST2. So therefore, total AST is equal to AST1, it is 2203.04, 2203.04 plus it is how much? 549.17. So if you add this, you will get the total area of steel. You will get the total area of steel, 2752.2 mm square. So now we got the total value of AST. बघा आता आपल्याला कुठली व्हॅल्यू मिळाली, इथली व्हॅल्यू मिळाली. तर AST काय असणार आहे? 2752.21 इथली व्हॅल्यू मिळाली. ह्याच्या आधी आपण इथली व्हॅल्यू कॅल्क्युलेट केली, परत ही AST2 कॅल्क्युलेट केली. दोघांना ऍड केल्यावर आपल्याला ही व्हॅल्यू मिळाली 2752. ओके. So now assume suitable bar diameter and calculate the number of bars. Okay, so assume 25 mm dia bars. Therefore, number of bars is equal to, number of bars is 2752.2 divided by 5 by 4 into 25 square. 0.6, okay, 5.6, so nearly equal to 6 numbers. So here I can write provide 6 bars of 25 mm diameter on tension side. Okay, on tension side.